So our log cosmic catalog today, graph f of x is log base 2 of x minus 3 plus 1. Remember when we graphed exponential functions, first thing I told you to do was always graph your horizontal asymptote. Well, now for your log function, graph your vertical asymptote first. H is the vertical asymptote. This is x minus 3, so h equals 3. Over here, vertical asymptote when x is 3. Because if x is 3, 3 minus 3 is 0, and you get log base 2 of 0. You have to evaluate that, see what does that equal. Well, it means 2 to the something power equals 0, and that's impossible. There's no answer to that. So that's why the value or the argument, this expression cannot be 0. Next, for graphing logs, it's usually easier if we just make a table and pick values for f of x, not x, or pick values for f of x. It's good to know the x-intercept when it's going to cross the x-axis. So let's say when f of x is 0, we'll solve for x. Okay, so solving this log expression, subtract 1. Okay, once you get to this point, you may or may not have watched a video on solving log equations yet, but when your variable, I say, is trapped inside of a log, it's the log, and it's inside the parentheses. To get it out, you go to exponential form. Exponential form is the base 2 to the negative first power equals x minus 3. Now there's no more log. This is 1/2. Add 3, we get 1/2 plus 3, say 3.5, or in proper fashion, 7/2. So what x is 3.5, f of x is 0. So there's our x-intercept. It's a good time to pause for a second and review what our function is going to look like. A log function, let's see, base 2, and it's positive, so it's going to look like this shape. It's going to approach the asymptote as you get closer to 3 and be this direction. Let's find out what x is when f of x is 1. Solving this equation. Subtract 1. Again, we want to know what x is. X is inside the log, so go to exponential form. 2 to the 0 power equals x minus 3. 1 equals x minus 3. And x is 4. 4, 1. How many points did I say for exponential function? 0 points when you graph an exponential function?
3.
Okay, so let's go 3 for a log. What's x going to be when f of x is 2? Subtract 1. Exponential form now. 2 to the first power equals x minus 3. 2 plus 3 is 5. X is 5. F of x is 2. Okay, we got 3 correct points. We have an intercept, which is good. We won't have a y-intercept because the function will not pass our asymptote. Now draw a correct shape. Log function should look like this. Okay, so our domain, what can x be? Our asymptote's at 3, so from 3 and then to the right, or 3 to infinity. Make sure parentheses for both. There should not be a bracket for 3. The function does not touch that asymptote. Range, let's see, down forever, and it's leveling off very quickly, but still increasing forever, so that's negative infinity to infinity for the range. Y can be anything. This function is all increasing throughout the whole domain, which means it does not decrease. We calculated the x-intercept earlier when we said, what's x when f of x is 0? So we already did that calculation, so let's write 7/2 comma 0. Y-intercept. Here's the y-axis. It doesn't cross it, doesn't touch it. Say NA or none. No horizontal asymptote. Make sure you write your vertical asymptote as an equation. Vertical lines are x equals 3. No max, no min, and this function is 1-to-1, meaning it has an inverse, which is the exponential function.